How does your body process medication? Slow version. Have you ever wondered what happens to painkillers like ibuprofen after you swallow it? Medicine that slides down your throat can help treat a headache, a sore back, or a throbbing sprained ankle. How does it get where it needs to go in the first place? The answer is that a hitch is right in your circulatory bloodstream, cycling through your body in a race to do its job before it's snared by organs and molecules designed to neutralize and expel free substances. This process starts in your digestive system. Say you swallow an ibuprofen tablet for a sore ankle. Within minutes, the tablets start disintegrating as acidic fluid in your stomach. The dissolved ibuprofen travels into the small intestines and across the intestinal wall into a network of blood vessels. These blood vessels feed into a vein, which carry the blood and anything in it to the liver. The next step is to make through the liver. As the blood and drug molecules in it travel through liver blood vessels, enzymes attempt to react the ibuprofen-free molecules to neutralize them. The damaged ibuprofen molecules, called metabolites, may no longer effect as painkillers. At this stage, most of ibuprofen makes it through the liver unscathed. It continues its journey out of the liver, through the veins, into the body's circulatory system. Half an hour after you swallow the pill, some of the dose has already made into the circulatory bloodstream. This blood loop travels through every limited organ, including heart, brain, kidneys, and back through the liver. When ibuprofen molecules encounter a location where the body's pain response is in its full swing, they bind to specific target molecules that are part of their reaction. Painkillers like ibuprofen block the production of compounds that help the body transmit pain signals. As more drug molecules accumulate, the pain-canceling effect increases, reaching a maximum within about 1 or 2 hours. Then the body starts to efficiently eliminate the ibuprofen, with the blood dose decreasing by half every 2 hours on average. When ibuprofen molecules detach from their targets, the systemic bloodstream carries them away again. Back in the liver, another small fraction of the total amount of blood gets transformed into metabolites, which are eventually filtered out by the kidney in the urine. The loop from liver to body to kidneys continues at a rate about 1 blood cycle per minute, with a little more drug neutralized and filtered out in each cycle. These basic steps are the same for any drug that you take orally, but the speed of the process and the amount of medicine that makes into your bloodstream varies based on drug, person, and how it gets into the body. The dose instructions of medicine labels can help, but they are average based on a sample population that does represent every consumer. And getting the dose right is important. If too low, the medicine won't do its job. If it's too high, the drug and its metabolites can be toxic. That's true of any drug. One of the hardest groups of patients to get the right doses for the children. That's because how they process medicine changes quickly as to their bodies. For instance, the level of liver enzymes that neutralize medication highly fluctuates during infancy and childhood. And that's one of the many complication factors. Genetics, age, diet, disease, and even pregnancy influence the body's efficiency of processing medicine. Someday, Routine DNA tests may be able to dial in the precise dose of medicine personalized to your liver efficiency and other factors. But in the meantime, your best bet is reading the label, consulting your doctor or pharmacist, and taking the recommended amount with the recommended timing. One more with normal speed. Have you ever wondered what happens to the painkiller like ibuprofen after you swallow it? Medicine that slides down your throat can help treat the headache, a sore back, and throbbing streaming ankle. But how do you really need to go in the first place? The answer is that a heat is right in your circulatory bloodstream, cycling through your body in a race to do its job before it's snared by organs and molecules designed to neutralize the expelled foreign substance. This process starts in your digestive system. Say you swallow an ibuprofen tablet for a sore ankle. Within minutes, the tablets start to distribute in the stomach. The dissolved ibuprofen travels the small intestines and the cluster intestinal wall into the network of blood vessels. These blood vessels feed into veins, which carry the blood and anything in it to the liver. The next step is to make the through the liver. As the blood and the drug molecules in it travel through the liver blood vessels, enzymes attempt to eject the ibuprofen molecules to neutralize them. The damaged ibuprofen molecules, called metabolites, may no longer be effective as painkillers. At this stage, most of ibuprofen makes it through the liver unscathed. It continues to journey out of the liver through the vein into the body's circulatory system. Half an hour after you swallow the pill, some of the dose has already made into circulatory bloodstream. This blood fluid travels through every limited organ, including heart, brain, kidneys, and back through the liver. When ibuprofen molecules encounter location with the body pain response is in full swing, they bind the specific target molecules that are part of a reaction. Painkillers like ibuprofen block the production of compounds that help the body transmit pain signals. As more drug molecules accumulate, the pain cancelling effect increases, reaching a maximum with about 1 or 2 hours. Then the body starts efficiently eliminating ibuprofen, with the blood dose decreasing by half every 2 hours on average. When the ibuprofen molecules detect from a target, the systemic bloodstream carries one away. Back in the liver, another small fraction of the total amount of drug gets transformed into the metabolites, which are eventually filtered out by kidneys and urine. The loop from the liver to my kidneys continues at a rate about 1 blood cycle per minute, with a little more drug neutralized and filtered out in each cycle. These best stacks are the same for any drug you take orally, but the speed of process and amount of medicine made into your bloodstream varies based on the drug, person, and how it gets into the body. The dose instruction on medicine label can help, but they are averaged based on the sample population that does represent every consumer. And getting the dose right is important. If it's too low, the medicine won't do its job. If too high, the drug and metabolites can be toxic. That's true of any drug. One of the hardest group of patients to get the right dose for our children. That's because how they process medicine changes quickly as to their bodies. For instance, the level of the liver enzyme that neutralizes medication highly fluctuates during infancy and childhood. And that's just one of many complicating factors. Genetics, age, diet, disease, and even pregnancy influence the body's efficiency of processed medicine. Someday, routine DNA tests may be able to dial in the precise dose of medication personalized to your liver efficiency and other factors. But in the meantime, your best bet is reading the label and consulting your doctor and the recommended amount with the recommended time. Today's video is talking about the medication and how our body processes this medication. At the first time, the speaker talking about the painkiller ibuprofen and how it it works in our body. After taking this medication orally, this medication go to our small intestine, and then it's gonna be observed by intestine well. Then this medication going to go to the vein, and finally it can have the function to release the pain, headache, and some pain. After then, it can go to our kidney, and then finally it's gonna be go out from our body. The most important thing to take the medication is that to keep the right dose, especially children and infant is very fragile about the overdose of medication, because right dose of medication, as I mentioned, right dose of medication is very important, because if the dose is lower than the average, it means it doesn't any work. And if people will take the more medication than recommended dose, it's gonna be toxin to our body. In the future, maybe people can develop the right amount of medication depending on people by DNA. But now we need to keep an eye on it before taking the medication, which is recommended time and recommended dosage from pharmacy or doctor. Yes, that's what I watched today video. Thank you.